Alrighty, so the first step to doing this is actually writing our syntax analyzer. So we're going to be using basically the visitor pattern here, and every time that our syntax analyzer walks the tree, and it's going to do so automatically, by the way, and we know that by if we just decompile the C# syntax walker or download the source. This is decompiled. We'll see that the visit method is actually performing a recursion on itself. It's telling the node to accept the visitor, and then the node itself will choose which one of the other methods to visit on. And we also have this default visit node as well. And you'll notice that we also have, inside of our C# syntax visitor, we have all of our other guys, our visit postfix unary expression, very specific, that's just going to be calling his default visit method, and the default visit method will just have the node accept itself. So it's a very basic visitor pattern. And so the cool thing about this, by the way, is, well, the cool thing and the maybe not so cool thing, depending on what exactly you're doing with the parser, is that this all happens, that the whole parsing phase happens before the visiting phase. That means that, for example, the visit namespace declaration will happen when it hits, for example, in fact, it'll be very useful if I leave one of these files up here up, or maybe this one, whoa, not that, maybe this one, because it's a little more complex. What's going to happen here is, when we hit this namespace declaration, this is going to be invoked, this method right here, visit namespace declaration. But the declaration node, the namespace declaration syntax node, is going to be populated already by the time we hit it. And that's very useful because it means that instead of me having to write an let's say do an override for visit method declaration and keep track of which interface I'm currently looking at, because you know the visit interface declaration is going to come next, and then it's going to go in here and then invoke the visit method declaration. But the cool thing about it being already parsed is that the interface declaration is going to have all the information I need. So, in fact, I don't even need to call through the base on this particular instance for the visit interface declaration unless I'm skipping it. Well, even if I'm skipping it, I don't need to call through the base. And that's actually kind of slightly a performance consideration if you think about it, because if I don't call base.visitInterfaceDeclaration, then it's not going to even bother opening up and recursing into this part of the tree. It's just going to skip right over it and skip to the next interface. Anyway, so now that we have that all done, let's go ahead and start off with our visit namespace declaration. This can be pretty straightforward. The first thing we're going to do is we're going to say underscore namespace stack dot push node dot name dot toString. Then what I'm going to say is using directives dot add, and then I'm going to say string dot format using placeholder semicolon, passing in string dot join dot and namespace stack, and then finally namespace stack dot pop. So what am I doing here? Well, in fact, what are these using directives? Why am I keeping track of these using directives, and why did I make it a hash set? Well, the reason comes back to the problem with the types. The problem with the fact that I don't have full type names for the types that I'm using in these files. I don't have a full type now. I don't have a full type object. I don't have reflection. I don't have any of that. All I have was what the user literally typed in. And if they said something like, if they made a class inside of this, like let's say public class hey, right? And then they made a method here that takes in a hey, now we have a problem, because if I implement this interface in a completely different namespace, right, that takes a hey, but doesn't qualify what namespace it came from, we're going to have a problem. See, watch this. If I say namespace generated down here, let's pretend this is our generated namespace, and I say public class proxy implements iLogin system client, and then I say public void basic client test int count hey. This will work because ReSharper decided to add a using statement up top. Let me fix that so I can make this a little bit more obvious what I'm getting at here. Okay, so pretend, no, stop that. ReSharper really wants to add that using statement in. So pretend that this is in a separate file. This is in our generated code, and this is our proxy. And this is what the user typed in to create that proxy. Notice the problem here. The problem is that this class was defined in this namespace, but this class didn't need to get imported at the top because it was in the same namespace. But then when we try to generate the file based only on the information we have here, we have no idea what namespace hey comes out of. We're going to have an error. We're going to have an error because we don't know what namespace that came from. So the solution, of course, is to keep track of all the namespaces that we go into as we're parsing these and add them as using statements at the top. Because watch this. If I add that using statement, well, of course, I have to add that at the top of the file. If I add this using statement to our generated file, notice how the error goes away. So all I need to do to prevent this particular edge case, this particular scenario, is simply keep track of all the namespaces that I enter and automatically add them as a using statement at the top. And we use the namespace stack, which, by the way, this should be namespace stack.reverse. Sorry about that. Because the stack is in opposite order. So what's going on here is we're simply just keeping track of all the namespaces that we're entering and pushing them on a stack, then visiting the namespace declaration and then popping them. And because this is a recursive depth-first tree traversal, all of the stuff inside of this namespace is going to happen on this base.visit namespace declaration code, or invocation, rather. Okay, so that's our visit namespace declaration, and that's what we're using our using directives there for right now. But another problem that is very similar. What if the user does hey, right? But he imports he imports the namespace at the top. So he says using buzz mmo.base.whoa. Like, for example, whoa is where hey comes from. We need to keep track of all the using statements that are used and then reapply them to the generated file so that they get re-imported. Because assuming that this is valid code, we want to make sure that this is used properly. Or that our namespaces are identical to what we parsed out of this. So our visit using directive is simply going to say we're going to replace the entire line with using directives .add node.toString. A couple points of interest here. First of all, using directives, I didn't mention why it's a hash set. The reason why it's a hash set is that if there's any duplicate using directives, I want to get them eaten up and removed. Hash set will only allow unique items, unique values to be inside of them. Next up, I actually did a very, very careful thing with doing node.toString. What does node.toString do? It basically just returns the node as the original programmer wrote it. Now, why is that important with the using statement? Well, it's important because a using statement has two syntaxes. It has this syntax, but it also has using hey equals buzz mmo dot base dot infrastructure dot mapped method, for example. So notice how this code now works because I'm using a using directive and I'm using it to alias a class. So I want to be able to handle both instances, and it's very easy to handle both instances because I literally just have to take what the programmer typed and add it directly to our using directives and use that as that code. And now the using directives is again just going to be simply inserted at the top of the generated file. All right, so now let's go ahead and say visit interface declaration. So the first thing I'm going to do here is I'm going to throw out all interfaces that don't have a attribute that we need. So what I'm going to do here is I'm going to say var attributes. I'm going to do this in two steps. It's going to be slightly suboptimal, but I want to do this so the code is a little bit more clear. I'm going to say equals node.attribute list. Now remember, node is of type interface declaration syntax. We're going to do attribute lists dot select many. T goes into T attributes. Then what I'm going to do is I'm going to say if attributes dot all. T goes into component attributes dot all, and I don't know, A goes into not T dot name dot toString dot ends with A, then return. Okay, so a couple points about this code. It looks a little ugly, I know, but it's straightforward if you know what you're looking at. First of all, what are these attribute lists? Well, basically in C#, it's valid to add as many attributes as you want to something, right? So I can add, well, in this case it's not because I marked this attribute as a one-use-only attribute, but you can add, pretend these are different attributes. You can add multiple attributes by putting in commas, but you can also put in as many attribute lists as you want. So an attribute list is simply a collection of attributes contained within the square brackets. So what we have to do with this code is to get a list of all the attributes that this interface has, is we have to access attribute list, and then we have to select many on its attributes, which is essentially going to flatten all of the attributes in all of the attributes list into a single collection. Then we say, if all of the attributes, and then we do kind of a Cartesian product on our component attributes, where we compare every attribute with every component attribute. Even though the component attributes array will most likely just be one attribute, again, we're supporting multiple attributes in this case. .all, and then we're saying does not equal t.name toString ends with. And the reason I do that there is if for some reason a person wanted to fully qualify an attribute. So for example, somebody wanted to say buzz mmo.base.infrastructure.component component interface. So if somebody wanted to fully qualify the name of this attribute, I went ahead and did a .ends with instead of a comparison. Also notice that I'm doing t.name because remember t comes from an attribute and he is a attribute object, so we have to access his names token out of the token stream. Okay, so now that we have that all figured out, let's go ahead and start off with, I'm just going to alias some stuff out just to make it a little bit clearer what's going on. I'm going to say var component name equals node.identifier.toString. I'm going to say methods equals new list of proxy component.method. Then I'm going to say method index equals 0. Now I'm going to go ahead and loop over all the methods inside this interface. I'm going to say for var method in node.members, so members is all the members that are appearing within the interface we're looking at, .of type method declaration syntax. So method declaration syntax is the node that we're wanting to look at for methods. Now we're looking at methods. So I'm going to say var method name equals method.identifier.toString. I'm going to say return type. Now this will be interesting. I'm actually going to be delegating the responsibility of parsing the return type to a helper method. So I'm going to say get method return type. It's actually going to return a toString tuple method. And then I'm going to say var parameters. Now we can get this all onto one statement. It's pretty straightforward. We're just going to do method dot parameter list dot parameters dot select. And then I'm going to say p comma I. So remember the select link method. It has a rarely used overload where we can pass in a function that takes in the object itself, which is represented by this p parameter, and then I, which is the index that the object appears in. And we're going to use that to index our parameters. So I'm going to say equals new proxy component dot parameter, passing in I for the index. For the name, I'm going to pass in p.identifier.toString, and for the type, I'm going to pass in p.type.toString. And then I'm simply going to say toList. Now, this toList is important. We want to flatten out this entire operation here so that we're not repeating this code every time we access the parameter list. Then finally, I'm going to do methods add new proxy component method, passing in our index, which is method index plus. We're going to want to pass in the method name, the parameters. Then we're going to want to pass in our return type. So I'm going to say return type. Remember I said that return type is going to be a two-tuple, meaning a tuple with two items. The first item is going to be the return type. The second one is going to be the return type name. So we'll do return type dot item 2 right there. I know this isn't going to compile because this method doesn't exist and we used implicit typing on the return type. But the moment we get this method in, this code will compile. Finally, all that's left in our visit interface declarations is simply components.add new proxy component, passing in our component name. For our namespace name, we're going to pass in string dot join dot on namespace stack dot reverse. And then we're going to pass in methods for our methods. And that's it. Okay, before we write our get return type method, I'm going to go ahead and finish off the visit class declaration. Now, we're going to cheat with this. It's very interesting cheat that we're doing here. Because you'll notice what I'm doing is I'm pushing the name of the class onto our namespace stack and then popping it immediately after. Now, what I'm doing is I'm cheating. Some of our interfaces are going to appear inside of nested classes. In fact, we already have an example of that. If I hop out of full screen right here, I'll show this code in a second if you guys want me to pause on that. But I'll jump here into my test right now just to explain what I'm talking about, why this is necessary. You notice that some of our interfaces that we want are inside of classes. And fortunately, the syntax to access a nested object or a nested class or interface from a parent class is the same as accessing a class that exists within a namespace. So that's very convenient for us. So I can kind of add in the support of having interfaces that appear within a class by simply pretending that it's a namespace for all intents and purposes. And so I do that by pushing and popping it off. All right, so let's go ahead and write our get method return type method. Now, this is going to be interesting because, again, we only have what we see right here to go off of. We don't have our component map. We don't have reflection. We don't have any of that. So what we really need to do here is I'm going to write a regular expression that's going to both extract the return type if it has any, or determine if it returns void, or if it returns a result, or if it returns a result with a response. And so the regular expression I'm going to use, I'm actually going to go ahead and pop this open for you guys. I love this website. As much as I hate regular expressions, this website makes me slightly happy. So what we need to do is we need to match a couple things. So we need to match void. We need to match our IRPC response. We also need to match our IRPC response string, for example. And we also should be able to add do buzz MMO dot IRPC response of bool, and we should also be able to do this without a response, and none of this stuff should match. So we have all the stuff that needs to be able to match with our regular expression, and we need to be able to extract this information. So the regular expression I'm going to do, the first thing I'm going to do, of course, is I'm going to use the G modifier up here so that it'll parse the whole text. First thing I'm going to do is I'm going to capture a group, and I'm going to say anything, question mark, IRPC response. So I'm capturing a group that has anything followed by the literal IRPC response. Then I'm going to open up an optional group. So I'm going to open up parentheses and put a question mark at the end. And I'm going to go ahead and put in a open and close bracket there. And then inside this, I'm going to put in another group, and it's going to be anything 0 to many times, well, 1 to many times would be more appropriate, followed by non-greedy. And as you see here, we have successfully matched our IRPC response return types. Notice how we get a match on this line, even though we have this prefix to the namespace. We get a match on this line as well without a prefix. We don't get a match on void, which is good. We get a match here, but more importantly, we extract the generic type parameter, or in this case, a type argument. We extract it right from the line. So this will allow us to properly parse our return type. So what I'm going to do is, before I write this, I'm going to go ahead and close that for now so it gets out of the way. Before I write this method, I'm going to write the regex. So I'm going to scroll up to the top, and I'm going to say private, B Sharper failed me again. Private static read-only regex, regex, there you go. Return type regex equals new regex, and I'm simply going to open up quotes, and I'm just going to paste in that regex that we just wrote, and I'm going to pass in regex options dot compiled into its options parameter. So go ahead and take a look at that code real fast. We're about to hop back down and finish off this class. All right, so we're going to jump down here, and I'm going to write a private method. It's going to return a private tuple of mapped method return type and string. I'm going to call this get method return type. It's going to take in a string, or it's going to take in the whole method. Method declaration syntax method. Then I'm going to say var return type, and this is us extracting the string representation of the return type. Method.returnType.toString. I'm going to say if return type equals void, well, that was easy. We can simply return tuple.create map method return type.void, and then cast to string null. Now we have to use cast to string null for our generic type inference. If we didn't have the cast to string there, it wouldn't be able to infer this the which overload to use here. Now, of course, we could specify the generic type arguments manually, but that would be a lot more verbose. So instead, we're just going to have this weird-looking cast-to-string null code right there. Next up, let's go ahead and use our awesome regex. So I'm going to say var match equals return type regex, whatever I call that, return type regex. Yeah, I was right the first time. Dot match return type. Then I'm going to say if not match.success, throw new invalid operation exception, which is going to be string.format method blank does not have a valid return type found blank. And we're going to pass in method.identifier, and we're going to pass in return type for the second parameter there, or second argument. Next up, I'm going to say var result type equals match.result3. Now, the third match is going to be the second group inside of our regex. And that's because the 0th match, the 0th match is always going to be the whole regex that was matched. And what I want the third group. So this is the first group. This is the second group. This is the third group. So I want the text right here. And to do that, we access the third match result. So I get match result 3. But if it was a... where are you? There you are. If it was just a normal IRPC response without a generic type argument, the second and third match will be blank. So that's how I determine which one it is. So I say simply if string, if string is null or whitespace result type, then return tuple create, and I'm going to go ahead and pass in response, and then I'm going to go ahead and pass in result type as the second parameter, just so I don't have to do that weird string cast. It'll be more clear if I did, actually. There we go. Then finally, if it got this far, we know it's a response with result, passing in result type. Now, I know I could turn this into a ternary if I wanted to, but I mean, I really could, but I'm not going to. Anyway, so that's the get method return type. In fact, we're pretty much done with our syntax analyzer. So just go ahead and take a look at that. I'm going to slowly scroll up here. And then what I'm going to do is I'm going to hop over into my generate command. I'm going to go ahead and put a breakpoint right there in generator, and I'm going to hit F5. And I'm going to see if it actually did correctly parse out all of those different things. So first of all, we notice that we have an error. IRPC method of int did not successfully match. So what is going on here? IRPC method of int did not match. What did I break? I'm pretty sure that's what I wanted. That really shouldn't make a difference. Huh. Well, this is interesting. Let's see here. Oh, derp. I was using the wrong thing. I should have been using IRPC method. Using the wrong string literal. Ignore me. Be sure you update your regex too. Okay, let's go ahead and see what the syntax analyzer analyzed. We have two using directives, base infrastructure and base.components.systems. I'm more impressed about this base component systems one because that means it did realized that we were in the base component systems and automatically imported it for us. That's where our interfaces appeared. For our components, we have 4 components. This one has one method. So this full name is correct. The name is correct. The method is correct. Return type void, parameters 0. Let's go ahead and take a look at a more interesting component here. iLogin system has 2 methods. Let's take a look at this method. Basic test has 1 parameter of int count with an index of 0. Now let's hop over to the second method, do something. Notice how the return type is response with result, and it returns an int. It has 1 parameter, and it's a boolean called should fail. So I think that's pretty good, actually. It was able to parse out all the things that we threw at it. So now, all we have left before we integrate this into the rest of the project is we have to jump into our actual code generator. And this isn't going to be a whole lot of fun because we're basically going to be copying and pasting all this code and sort of massaging it to work with the new interface. But that's what we'll be doing in the next video. So until then, we'll see you guys later.